took 1 minute from Mario from TigerGraph, but because it's the same name like you, Mario, I said, no problem. We can steal 1 minute from him. Thanks a lot, Mario from Unica. You can switch off the camera. It was amazing. Thanks a lot.
Thank you, Musin.
Thanks a lot. So now I'm expecting Mario the second from TigerGraph, Mario Werner, to join us. Mario, I give you the co-host option again. Sorry, I don't know why I dropped. Now you can join again, Mario, with the co-host option. Perfect.
Okay.
Yes. So welcome on board.
Hello.
Yes. Mario, happy to see you. I hope you had more chance in the morning to be with us, but I think you were busy at that time.
Yes, exactly. A lot of things going on here.
Yeah, happy to see you. Happy to see you with us. If you can prepare the screen for sharing so that we can double check it till I introduce you and the topic. So Mario is the regional manager DACH for TigerGraph, accelerating global intelligence with graph is his presentation, how Jaguar Land Rover are responding to challenges in 45 minutes instead of 3 weeks. Just to give you a feedback from last event we had it for North Europe where TigerGraph was there. The presentation was so interesting that people had a lot of questions. So I hope as well, Mario, you give us time for Q&A so participants can ask you a lot of questions. Go ahead. Thanks a lot. We can see everything now.
Yeah, thanks, Musin. Mario the second. So very good organization. So it's very easy for everybody to keep our both names in mind. I'm working in the customer-facing team here in the DACH region for TigerGraph. And I do see in the audience actually some people that I met over the last couple of months. So I think some of you are already aware of TigerGraph and what we're doing. To those who don't, I hope that I can get some. So it gives you some insights in what graph analytics and graph databases can bring to your organization. I mean, actually, graph databases are around for a while. So I would say in the second half of the 2000s, commercial graph databases became available. Anyway, market researchers from the likes of Gartner predict that this market is now about to gain share dramatically, at least over the next couple of years, where graph analytics is being seen as a crucial technology in the vast majority of data and analytics innovations. I think that is also part due to the amount of data and the speed of processing that we can handle now today with modern graph databases and graph analytical systems. And before I talk about what Jaguar Land Rover did in the last 2 years with using TigerGraph to augment their supply chain management system as one potential use case, I would like to first introduce a little bit what TigerGraph is about, so that I make sure that everybody gets a fair understanding of the offering that we have. Before I do that, just to make a starting point, I would like to bring this quote here, so to kind of set the stage what this is going to be about, and that is a quote from JLR's Director of Data and Analytics, Harry, who is doing a lot of presentation for us in our own conferences and in third-party conferences. Unfortunately, he couldn't make it to this specific event. What he says about TigerGraph, amongst others, is that using that technology, they can join sources of data together and make connections within that data that previously they couldn't, and that they can now answer questions that they have never thought of that were possible to ask. And what he means is being what will be what I'm going to present in the second part of my talk here. And just to set the stage with the basics, I know that I would say the majority of you are aware of what a graph database is. Just to repeat it very briefly, so a graph database is actually a storage model that does not use that files, and we do not store tables with rows and columns like those relational database management systems do. So a graph database basically consists of vertices or nodes and edges. Vertices are the data, the actual data entities, so real life things, so to say, and the edges represent relationships between those entities. A graph stores these relationships between data entities and can also be used to uncover and analyze these more hidden relationships between the data entities. And what I mean by that is going to be clear in a minute. Why are people and companies using graph analytics? So what value do we bring? I think we have heard about this siloed data and connecting data from different business units, from different departments. Maybe also we can make a separation between company internal data and company external data. And our customers are using TigerGraph or graph analytics to connect all these data sets and data pipelines. And that is possible because we are based on a distributed architecture. So that means that we can frictionless scale from, I would say, from tens of gigabytes to terabytes. And we are already working on a petabyte scale graph database. So I mean, just one database that holds tens or hundreds of terabytes, and over the next couple of, let's say, year or 2 years, we are working on scratching the petabyte scale with one graph database instance, and thus enable these companies and our clients to connect literally hundreds of data sets and pipelines into one graph analytical system. Then, of course, it's about not only connecting these data sets and pipelines, but also analyzing these data sets and pipelines. And as we will see later, this can lead to dramatically reduced response times in terms of the queries, which enables then organizations to use such a system as a real-time analytics system, an operational system, not so much as a historical analysis, but more like an operational analytics system for supply chain planning, but also for fraud detection. And then we can, or our clients are also using these connected data sets and the analytics that we run on these connected data sets to continuously generate what we call graph-based features and load them into their existing training models. So to enrich those training models with graph analytics. And what makes especially TigerGraph so interesting, that is, in short, from the architectural point of view, it's two things. It's the distributed nature of the actual database, which, like I tried to explain, enables the database to scale to tens and hundreds of terabytes, and soon into the petabyte range, meaning that we can put hundreds of data sets with a massive amount of data into one analytical system, and enable this, what we call a deep link and pattern discovery. Again, that with very high speed. And then this massively parallel processing engine, which means that you can run these analytical queries evenly spread across all these nodes. I mean, the hardware nodes or the compute nodes that build up these graph database cluster. So you have a very high ingestion and update rate. And on the other hand, you have a very low latency when it comes to the response time of the actual queries that you run on these large data sets. So that is why we have these customers that are using us at a very large scale for these real-time operational analytics use cases, where supply chain management is one of them. So what are the, let's say, the key capabilities, data science capabilities that are powered by such a native parallel graph system? That's the, if I start from the left to the right, it's the link analysis. So for a set of entities, which are these circles, and that can be any type of things. Show me all links, all indirect links, and hidden links between these data entities. We can identify patterns, so we can query a certain pattern. In that example, the second example, you have a query that would be something like, where are patterns that have 2 orange and 1 blue ball, and then you would be able to find all those matching patterns within this graph database by sending that query across that database cluster. So pattern detection, commonality discovery, so finding similar data entities just by searching through their direct and indirect links. Sorry. And the fourth group of algorithms are obviously algorithms that are about to identify groups of data entities that define a community with a high rate of interaction or a high rate of links between these data entities, and also identify a central hub, which is then obviously the most active entity within that community, identify these communities, which can be what we're going to see at this Jaguar Land Rover example. Also very interesting for example, to identify where do I have supplier risks, how can I score these risks, and how can I also mitigate these supplier risks, for example. We can then add also geodata into the analysis to analyze change in entities and relationships based on their geographical locations. We can add time series data to analyze these changes in entities in relationships over time. And again, we can, I think I already mentioned that we can extract these graph-based features and feed them into the existing machine learning frameworks to further increase the training data set. So that's a little bit the description of graph database, graph analytical system, and obviously, especially the difference of, let's say, the legacy graph systems compared to TigerGraph. Today I'm going to talk a little bit about supply chain challenges and how we augment supply chain complexities, how we ease those supply chain complexities. But there are obviously a lot more use cases that we are currently talking to and are implementing at customers across the globe. And that can be, these are many customers from financial services. When we talk about fraud detection, cyber threat detection, very big topic again, became 2 days ago in Germany. All kind of data lineage, customer 360, entity resolution type of use cases. So lots of use cases where there is one common challenge, and that is querying complex or asking complex questions on large complex data sets. Yeah? Let's talk a little bit about what Jaguar Land Rover did with our technology. I was talking about connecting data sets. And in the case of Jaguar Land Rover, one of their challenges was to, they had very disparate data silos. When you look at sales had their forecast data, then you had output from the car configuration application. You had parts data from the PLM system. The ERP system was had some data that they wanted to analyze as well. Supplier management, obviously supply chain data, and that was based on mainframe system. It was based in their cloud-based applications. And so a very dispersed set of data sources and data formats that they wanted to integrate into one system. And the connection challenge here is incomplete, as these are 9 different data sources, but Jaguar Land Rover was talking actually about 23 different databases, applications that they brought together into TigerGraph. And what they actually wanted to do is get this this complete view. If you look at this, and it's a simplified graphical display of their, what they call their demand and supply graph, where you see, let's say, this layer where you have the actual built cars on the very top, down to the layer of their supplier network at the very bottom. And what they wanted to do is they wanted to browse from the cars to features and parts of these features and the suppliers that are delivering those parts, to have a clear, let's say, how they call it, a two-way line of sight. So you can browse from the top to the bottom, or from the bottom to the top, and show all the dependencies from cars to features, parts, and suppliers. And that looks here in the simplified diagram. That looks pretty straightforward, but if you think of them having tens of lines of cars and potentially thousands of different car models, and then tens of thousands or even more features, and that kind of exponentially grows when you come to the layer where you display those parts. And this type of analysis, browsing through that graph, identifying indirect links between cars and parts and suppliers, for example, or identify patterns. This is actually what Jaguar Land Rover is doing with TigerGraph. And I have one example here, just cautious of the time, where one critical business question that they wanted to ask across this demand and supply chain graph was, let's imagine that the demand for a certain model is suddenly surging in the specific markets. Do we have all the parts that we need to meet this demand? Where do the supplier risks lie? And then they said, okay, with a graph, we are able to browse that graph to identify from the top down to these feature layer, parts layer, and supplier layer. So they can now make in a very short response time to their database queries. They can identify which suppliers are involved in the production of those parts and features of a certain car model. Are there any risky patterns like fan in and fan out patterns? Because a supplier might be a single supplier for too many for too many parts, like in this, like it's demonstrated in these red dots, or are there even worse parts that are only being delivered by just one supplier, and at the same time also identifying potential alternative suppliers? And that and this analysis, if you think of doing that type of queries against a relational database, first thing is getting all that data into a relational database, and then querying that data in that way would require, I'm not sure, tens of table joins, and that led, in the case of Jaguar Land Rover, and this is what we put in the headline of that presentation, to query response times of 3 weeks. And after implementing TigerGraph, loading all that data into one single graph analytics system, those queries, and that's this quote here again from Harry, those queries across the supply chain model now take, let's say, less than 1 hour compared to weeks using this relational database software. And I think that is pretty impressive, and you will get this presentation with the link after that event, so you can have a look at this CIO.com article to further get into the details. And if I think I have still a couple of minutes left before we start the Q&A session. Just a look at the architecture. So all their supply chain data was being stored and processed in GCP in that particular case, or with that particular customer. And they were using a relational database system to run those queries, which was provided by Google, and that was what led to those 3 weeks response times. And they started last year with using TigerGraph just for 2 very critical queries that they wanted to model in a graph database, by using the Google Cloud Storage raw log storage. And what they did was weekly batch loads that they then loaded after the data was transformed into a graph schema into TigerGraph, and it was processed in TigerGraph, and then it was reloaded into their relational database system, and then fed into their data visualization tool, which in that case was Tableau. And that was, with that batch loading, they reduced these query times from 3 weeks to less than an hour. And what the team is now currently working on, based on our TG Cloud IO, which is our software as a service product, they are now not only using those batches, but they are also using their event data. So a messenger service. So we are processing the data as it comes, OLTP in real time in TigerGraph, and can work on this, what I call this operational real-time analytics system. So this is the second evolution of their journey to this operational analytics systems. And we are talking now about response times below 1 minute, which then is a real operational analytics system based on TigerGraph. Results, decision speed obviously improved by 120x, 3 weeks to less than an hour. Business value, that goes back to lower inventory, lower working capital. That's also including the increased profitability, as they were able to analyze very quickly the impact of using parts for certain models in relation to the profitability of certain cars. So they could also increase the profitability of their vehicle sales by using TigerGraph. And obviously, by always having a look on the these fan-in, fan-out patterns and identifying supplier risks, they could add more suppliers to their these critical parts and feature groups, and thus they reduce their supplier risk by 35%. And that's all adapted from their presentation about their journey with TigerGraph. And yeah, having that said, I would I think we have a couple of minutes left for Q&A.
Thanks a lot. I would need more time, but we have 1 minute to see what are the questions that we can ask now, or we just see who has the question that we can follow up with them.
Yeah.
Thanks a lot. If you could be so kind to stop sharing the screen as well, Mario. Thank you so much.
Yeah. Okay.
Thanks a lot. So guys, let's do it this way, because we have just 1 minute left. We have made a LinkedIn group for all participants of this summit. And you could be so kind to join that LinkedIn group, so that you can get in touch with Mario and other colleagues to follow up if you have any questions with them. Let me just show you where the LinkedIn page is. I have to all the time repeat so that I make sure all the participants are on this room. Already 84 participants joined this room. This is not for marketing, only for participants of this summit. 270